Hello everyone. In today's video we are going to solve two more questions based on constant velocity problem in which the particles will collide and they will not collide. Let's get started. In this question, all lengths are in kilometers and time is in hours. Boat A sails with constant velocity from a point O with position vector 0, 0. After 3 hours, A is at the point with the position vector minus 12i plus 9j. Find the position vector OP of A at time t. As you know that we have the initial vector which is 0, 0 and he reached at the point A whose position vectors are also given to us minus 12i plus 9j. But in this case, we don't have the velocity vector. To write down the position vector after t time, we need the velocity vector first. So as we know that the position vector of A will be given by the initial position plus the time multiplied by the velocity vector. So let's substitute the values here. So the position of A is minus 12 and 9 here, which is equals to the initial position, which is 0, 0 plus time t is 3 hours and the velocity vector I don't know, so I suppose that that is x and y. So minus 12 and 9, which is equals to, so that will be 3 bracket x and y. So that will be written as minus 12 and 9, which is equals to 3x and 3y. Now I can compare the I and j vector separately. So if I compare the I vector, 3x is equal to minus 12. So x is equal to minus 12 over 3, which will be 4. So x is equal to minus 4. Now if I compare the j vector, 9 is equal to 3y. So y is equal to 9 over 3. So y is equal to 3. So the velocity vector will be given by minus 4, 3 and the initial vector is 0, 0. Now we will write down the position vector of OP after t hours will be given by A plus TV. Let's substitute the value here. That will be equal to initial vector is 0, 0 plus time t and the velocity vector. Velocity vector is minus 4, 3. So this will be written as t times of minus 4, 3. If you multiply that inside, it will be minus 4t and 3t. That will be the answer for the position vector of OP after t hours. At the same time, as A sails from O, boat B sails from a point with position vector 12, 6 with constant velocity minus 5i plus 8j. Find the position vector of OQ of B at time t. So they have given us the initial vector and the constant velocity also it is given to us. So the position vector of OQ of B at time t will be given by the initial vector plus time multiplied by the velocity vector. Let's substitute the value here. Initial vector is 12, 6 plus time t and the velocity vector. Velocity vector is minus 5 and 8. So if I solve it, that will be 12, 6 plus minus 5t and 8t. So if I add it, that will be equal to 12 plus of minus 5t and that will be 6 plus 8t. So which will be equal to 12 minus 5t, 6 plus 8t. Now show that at time t, modulus of PQ square is equal to 26t square plus 36t plus 180. Now I need to find out the length PQ and then I have to take the modulus of that. So the length PQ, if I write down in the position vector form, will be written as OQ minus OP. So the vector OQ is given by 12 minus 5t I, 6 plus 8t j. The vector OP is given by minus 4t I plus 3t j. So as you know that I have substituted the values here. Now I need to solve that. That will be written as 12 minus 5t minus of minus 4t, 6 plus 8t minus of 3t. That will be equal to 12 minus 5t plus 4t, 6 plus 8t minus 3t, which will be equal to 12 minus t and it will be 6 8t minus 3t is plus 5t. So that will be the answer for the position vector of PQ. Now I need to find out the length PQ. So the length PQ will be given by root of 12 minus t the whole square plus 6 plus 5t the whole square. Now let's open that first. That will be equal to 144 minus 24t plus t square plus 36 plus 60t plus 25t square. So if I add it, t square and 25t square will be equal to 26t square. 60t minus 24t will be written as plus 36t, and 144 plus 36 will be equal to plus 180. So modulus of PQ the whole square will be given by 26t square plus 36t plus 180, which is proved. Now show that A and B do not collide. So if they collide, their distance must be equal to 0. So that means 26t square plus 36t plus 180 is equal to 0. Now I have to solve this quadratic equation. Let's first see the discriminant. What is discriminant? B square minus 4ac. So the B square minus 4ac, the value will be B is 36 the whole square minus 4, A is 26 and C is 180. Now I need to solve that. 36 square will be given by 1296, and then minus 4 times 26 times 180 will be given as 18,720. So if you subtract that, your answer will be negative of 17,424, which is less than 0. So if our discriminant is less than 0, that means you can't find out the answer. That means they do not collide. Let's see one more example. A particle travels with a speed of 6.5 meter per second in the direction of minus 5i minus 12j. Find the velocity VA of A. So as we know that this is the velocity we have to find out, and this is in the direction of the vector minus 5i minus 12j. So as we know that the unit vector will be given by the vector divided by its modulus. So the vector will be written as, if you do the cross multiplication here, modulus of the velocity vector multiplied by the unit vector. So I need to find out the unit vector, which will be the same as the unit vector of vector B. So the vector divided by its modulus. So let's substitute the value here. That will be equal to the vector minus 5i minus 12j divided by modulus, which will be equal to minus 5 the whole square plus minus 12 the whole square. That will be equal to minus 5i minus 12j divided by root of 25 plus 144. So that will be written as minus 5i minus 12j over root of 169. That will be equal to minus 5i minus 12j over 13. Now I will substitute this unit vector here in the velocity vector. So the velocity vector will be written as the modulus of the velocity vector, which is 6.5. So that will be equal to 6.5 multiplied by the unit vector. Unit vector is minus 5i minus 12j over 13. So 13 will be got cancelled from 65 and your answer will be 0.5. So 0.5 multiplied by minus 5i minus 12j. 0.5 will be written as 5 over 10. So that will be minus 5i minus 12j. So 5 will be got cancelled and it will be 2 here. So our velocity vector will be given by half minus 5i minus 12j. That will be your answer. Now a particle B travels with velocity VB 12i minus 9j. Find the speed in meter per second of B. As we know that the speed is the modulus of the velocity and the velocity is 12i minus 9j. So the modulus will be given by root of 12 square plus of minus 9 the whole square. So that will be equal to 144 plus 81. That will be written as root of 225. So root of 225 is 15. That will be your answer for the speed. A particle starts moving from the point with position vector 20i minus 7j. At the same time, particle B starts moving from the point with the position vector minus 67i plus 11j. Find RA, the position vector of A after t seconds, and RB, the position vector of B after t seconds. So the position vector of A after t seconds is RA, the initial vector, plus time multiplied by the velocity vector. So the velocity vector is given to us as we find out earlier. That will be half minus 5i minus 12j, which will be written as minus 5 by 2i minus 12 by 2j. So that will be equal to minus 2.5 and is minus 6. And the initial vector will be given by 20 minus 7. So let's substitute the value here. So the initial value is 27 minus 7 plus time t multiplied by the velocity vector. Velocity vector is minus 2.5 and minus 6. So let's solve this. So that will be 20 minus 7 plus minus 2.5t and minus 6t. That will be equal to 20 minus 2.5t minus 7 minus 6t. That will be the position vector of A after t seconds. Now we have to find out the position vector of B after t seconds, which will be given by initial vector plus time multiplied by the velocity vector. So the velocity vector of B is given by 12i minus 9j, which will be written as a column vector as 12 minus 9. And the initial position of B is given by minus 67, 11. Let's substitute the value here. The initial position A is minus 67, 11 plus t times the velocity vector is 12 minus 9. So that will be equal to minus 67, 11 plus 12t minus 9t. So if I add it, that will be equal to minus 67 plus 12t, 11 minus 9t. Now, find the time when the particles collide and the position vector of the point of collision. So when the particles collide, we can equate the position vectors of A and B. So RA is equal to RB. As you can see that I have equated the values. Now in this I can equate the I vector separately and the J vector separately. So you will get the same answer if you equate both of them. So right now I will do it with only one of the vectors, J vectors, because it is easy for me to equate the J vector. So let's equate the J vector. So minus 7 minus 6t is equal to 11 minus 9t. Now move this minus 9 on left hand side. So it will be minus 7 minus 6t plus 9t is equal to 11. Now move this 7 on right hand side. That will be minus 6t plus 9t is equal to 11 plus 7. So minus 60 plus 90 is equal to 3t is equal to 18. So t is equal to 18 over 3. So if you got cancelled, it will be 6 here. This gives you t is equal to 6 hours. Now to find the position vector of the point of collision, this is obtained by substituting the value of t in the position vector of B. So this is the position vector of B. So I'll substitute the value of t here. So let's substitute the value. So it will be minus 67 plus 12 times 6 and it will be 11 minus 9 times 6. So that will be equal to minus 67 plus 72 and it will be 11 minus 54. If you solve it, that will be 5 and minus 43. So this is the answer for the point of collision of the two vectors A and B. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye-bye everyone.